All right, guys, so what we're doing today and what we'll be covering is in our trigonometric is verifying trigonometric identity. So when we verify a trigonometric identity, we're pretty much given an identity like this here, sine squared of x is equal to 1 minus cosine squared of x. We're given this identity and we're going to show that it's true. Now the way that we show that it's true is we either get the left side to be the exact same as the right or the right side be the exact same as the left. So for this here, if I wanted to show that it's true, is that I would work to rewrite 1 minus cosine squared of x as sine squared of x. And if I can do that, then I can prove that the identity is true. Now, when we're doing this here, we'll really need the reference, or I say the reference sheet, I mean a reference sheet, these here, that have all of our kind of properties to them. And we're going to be using these and manipulating these in such a way to be able to show that the right side is the same as the left or left is the same as the right, one or the other. Now, the first one we're going to look at is this here. We want to verify that this identity is true. That secant squared minus 1 over secant squared is equal to sine squared of theta. We want to show that this is a true statement. Now, there's many different ways that we can do it. And one of them is that first, what we're going to do is, the first main step that we're going to do is I'm going to utilize the Pythagorean identity. And the Pythagorean identity, that we want to use is this one here. 1 plus tangent squared is equal to secant squared. Now, they're probably going to utilize this a little bit and subtract the 1 and really say that tangent squared of u is equal to secant squared of u minus 1, because this is the same thing. They just minus 1 from both sides. And the reason this is useful is because, well, the numerator is secant squared minus 1. Or we can just plug in that, which I would do also. We can say that also, is that secant squared is equal to tangent squared of theta plus 1. Now, we're not going to change the denominator to do the same thing. I was tempted to do that. It's very tempting to just go on and change both, but we're just going to change the numerator. And we'll see why here in a second. Now, we can simplify it in that the positive 1 and negative 1 will cancel out. And we get this here. Tangent squared over secant squared. Now, they're going to talk about the reciprocal identity, the fact that secant is the same as 1 over cosine, or 1 over secant is the same as cosine. So it's going to come up to the top because it flips. Now, the quotient identity is saying that tangent squared is the same as sine squared over cosine, and well, the cosines would cancel out, leaving us with just sine squared, which is what we wanted. We wanted to show that the right side is the same as the left. And that's it. Now, it's all of this here is manipulating these formulas and manipulating these properties of sine, cosine, tangent, secant, cosecant, and cotangent so that we get what we wanted, or get the one side to be the same as the other. Now, we're going to do more of these here, and we're going to do these here. So 2 secant squared of alpha is equal to 1 over 1 minus sine of alpha plus 1 over 1 plus sine of alpha. And this is the first one we're going to do here. Now, I'm going to leave this side alone. I'm going to leave it alone. I'm going to mainly work with this side here. Well, it's probably going to be helpful if I have everything as one fraction. It's going to be a little bit easier to work with if I have one fraction. So what I'm going to do first is I'm going to add these. I want to add these two fractions together. But in order to add the two fractions together, I need the denominators to be the same. So to make the denominators the same, I'm going to multiply both sides by 1 plus sine of alpha. For this first one here. So for the 1 over 1 minus sine of alpha, I'm going to multiply the top and bottom by 1 plus sine of alpha. And for the 1 plus sine of alpha, well, to get it to be the same, I'm going to multiply it by 1 minus sine of alpha. Oh, it's so hard to write with the mouse. Because when I multiply these together here, it's going to make the denominators be the same so that I can add them together. 1 plus. Well, it's not going to be 1 on top. On top of this here, we're going to have 1 plus sine of alpha. And on top of this here, we'll have 1 minus sine of alpha. Now, something does happen interesting, because normally I would leave it as 1 minus sine of alpha times 1 plus sine of alpha. I wouldn't distribute and multiply those together. But for this one here, I will, because something will happen that's kind of interesting that's going to be helpful. So we're going to go on and multiply these through. Well, our 1 times 1 will give us 1 minus sine of alpha. So that'd be plus sine of alpha, not minus. We'd have 1 times sine of alpha, which would be plus sine of alpha. Negative sine of alpha times 1 would be negative sine of alpha, plus sine squared of alpha. And not plus, it'd be minus. Okay, So we'd have 1 plus sine of alpha Okay, so some things jumped around. I paused the video just for a second so you wouldn't have to watch me go through and get everything set up the way I like it, or kind of make it look a little bit nicer. Now, when we're doing the distributive property or multiplying through, 1 times 1 gives us 1. 1 times sine of alpha gives us positive sine of alpha. Negative sine of alpha times 1 is negative sine of alpha. And then negative sine of alpha times sine of alpha would be negative sine squared of alpha. Now, this here, what's in the middle? Sine of alpha and negative sine of alpha. These here actually cancel out, leaving us with just 1 minus sine squared of alpha. And we would have this on both, because that's what the denominator is going to be. Okay. So that's what we get here. So we have 1 plus sine of alpha and 1 minus sine of alpha on top, and the denominators are both 1 minus sine squared of alpha. Now we can add those two together. So on top, I would have 1 plus sine of alpha. I had to go get alpha back. And then we'd have 1 plus 1 minus sine of alpha over 1 minus sine squared of alpha. So far all we've done is we just have tried to get the two equations on the same, into the same fraction. We're just adding the two fractions together. And to do that, we multiplied, or we made the denominators the same and combined. Now we can still simplify a little bit further than this. So what we can do as well, our 1 plus 1 would give us 2. And sine alpha And negative sine alpha would cancel, so actually what's left on top is just going to be 2. So 2 is going to be the only thing on top. Now in the denominator, we have 1 minus, let's get rid of the underline, 1 minus sine squared of alpha. So we have this here. Sorry, I was changing the spacing. So we get this here, 2 over 1 minus sine squared of alpha. Okay, now we're closer to what we want. Now what I want is 2 times secant squared of alpha. Okay, now we're going to go back to our reference sheet. So we're going to go back to the reference sheet. So when I look at this here, so, well, I don't need that. Secant squared is what we want, or secant. Well, secant is 1 over cosine. Okay. So I look at this here. Well, hey, look, I have 1 minus sine squared. Well, 1 minus sine squared is the same as cosine squared. So really what I have here is the same as 2 over cosine squared. And really what we can say is I can replace sine squared with cosine squared of alpha. Because 1 minus sine squared of alpha is the same as cosine squared of alpha. Because of our Pythagorean identity, this here, sine squared of u plus cosine squared of u is equal to 1. Well, I can subtract sine squared. And 1 minus sine squared is the same as cosine squared. At this point here, I know that secant is equal to 1 over cosine. So for us here, 1 over cosine squared would be the same as, so we'd have 2, and I can replace 1 over cosine squared with secant squared. Didn't mean to put all that down there. Alpha. And that's it, because we have what we wanted. Because we wanted 2 secant squared of alpha, and we've manipulated it down to get 2 secant squared of alpha. And we're done. So a lot of this here is manipulating the equations to get them to what we want, or what we want them to look like. All right, so let's look at this one here. Verify that tangent squared of x plus 1 times cosine squared of x minus 1 is equal to negative tangent squared. Okay, so when we look at this here, there's different ways we can go about it. Now, one thing I'm going to do is I'm going to be using, and I'm going to be manipulating this side. We're going to leave this side alone. So what I want to do is I want to rewrite and see if I can rewrite tangent squared of x plus 1 times cosine squared of x minus 1 as negative tangent squared of x. Now the first thing we can do is we can go on and multiply these through distribute. So I can say tangent squared of x times cosine squared of x. So we multiply the first two together. So we distribute the first two here. Now we're going to multiply the next two. And when I multiply the next two, well, we'll get negative tangent squared of x. Well, hey, that's what we need. If everything else cancels out, then we're done. But we'll see. So we have this here. Now we're going to go to the next one. These here and these here. So 1 times cosine is going to be plus cosine squared of x, and then minus 1. Okay, so we have this here. Now it'd be nice if everything else cancels out, except for the negative tangent squared of x, because if it did, then we would have it all finished. Now looking at this here, let me get a highlighter so I can point something out. Well, this here is just a single term. It's just tangent. Here we just have cosine. So we have cosine, tangent. This here is the only one that I have more than one term. So let's see if we can simplify that. Well, hey, tangent squared of x is the same as sine squared of x over cosine squared of x. Okay, so I went on and manipulated this a little bit, but we can replace tangent with sine squared of x over cosine squared of x, because tangent is equal to sine over cosine, and tangent squared is equal to sine squared over cosine squared. Well, the reason that this is helpful is, well, hey, look, cosine squared and cosine squared, when we multiply these together, these two will cancel out. Okay, and this here is helpful. Because once we multiply these together, what I'm left with is, well, this wouldn't be tangent anymore. It's now we're just going to have sine squared because cosine squared and cosine squared canceled. And we have this here. Okay. Now the next thing I'm going to do is I'm going to rewrite this, move some things around. And what I'm going to move is this tangent just to the back. I'm going to move it to the back. I'm not really doing anything. I'm just moving the tangent squared to the back end. And the reason I'm doing this is I want to make it easier to see that we have sine squared plus cosine squared. And if we remember or look back at our identity sheet, well, sine squared plus cosine squared is equal to 1. So what that means for me is that I could rewrite sine squared plus cosine squared. I can rewrite this entire thing as 1 minus 1. Well, 1 minus 1 will cancel out, leaving me with just negative tangent of tangent squared of x. And what did we want? Negative tangent squared of x. So we verified that this does work. So again, it's just manipulating these equations so that we get what we want. Okay, so let's look at this next one here. Secant squared of x minus 1 times sine squared of x minus 1 is equal to negative sine squared of x. Okay, so let's just do what we just did on the last one. So I'm going to multiply them together. So we'll have secant squared of x sine squared of x, because we do our first multiplication. And we have minus secant squared of x minus sine squared of x plus 1. So I'm going to go on and make these all exponents so it's easier to see and we aren't thinking that that's an actual 2 in there. So we have this here. Oops, didn't mean to do that. Okay. Now, secant is the same as what? Okay, so let's see. Let's go back to our reference sheet. Secant is the same as 1 over cosine. Okay, so secant's the same as 1 over cosine. So secant squared is the same as 1 over cosine, but again, so we're wanting to get negative sine squared of x by itself. So it'd be nice to get this by itself. Okay, so let's see if we can do that. So that might be helpful. Well, we also have this secant squared. Okay, so let me highlight what I'm kind of referencing. So we have this here. We kind of need to simplify if we can. And then we also need to get rid of this here and this here, because if we can get rid of those, that's going to make it even better. Okay, so let's look back at our reference sheet. So we know secant is the same as 1 over cosine. We have this here. We also have this here. 1 plus tangent squared of u is equal to secant squared of u. Okay, so that might be useful. Let's start off with this here and see what happens. So, well, this here, secant squared times sine squared, well, secant's the same as 1 over cosine. So we have 1 over the cosine squared of x. Have this here. Times sine squared of x, all of this here. Now, okay, so that's kind of helpful, but really, if we multiply these together, what I get is sine squared of x on top Okay, so I paused the video and did some editing so that you don't have to see me do each of the individual steps to get this written out. But really, when we multiply these two together, these two here, we get sine squared of x over cosine squared of x. Okay, that's fine. But what do I know about sine squared of x over cosine squared of x? Or sine over cosine? Well, that's the same as tangent. So really what we have here is that I have tangent squared of x. I don't need all of this because this here is the same as tangent squared of x. Okay, that's fine. I'm going to copy that. So we've gotten to this point here. So really all I've done is I've taken that first part, secant squared of x times sine squared of x. Well, we changed secant into 1 over cosine. Well, that's the same as sine squared over cosine squared, which is the same as tangent squared of x. Well, I'm going to move this plus 1 down to tangent. Plus 1. And there's a reason I'm doing that. Let's look back at the reference sheet. 1 plus tangent squared is equal to secant squared. So I have 1 plus tangent squared, which really means that this here is I can replace it with this. Because that really we would have secant squared of x. Because again, this whole thing right here is secant squared of x. Okay, now why is that helpful? Well, I have secant squared of x minus secant squared of x. Well, these two would cancel out, leaving me with just negative sine squared of x. What did we want? Negative sine squared of x. So we're done. And that's it. Now, if you notice up to this point, we're not actually solving for anything. I'm not actually plugging in values and finding specific angles or lengths or kind of comparing sides. I'm just showing that the right side is equal to the left, or that the left is the same as the right. I'm changing one to get it to be the same as the other. And that's it. Okay, we want to show that tangent times cosecant is equal to secant. Okay, well, to do this here, I think it might be easier to convert tangent and cosecant into sine and cosine, because I'm going to work with this here. Now, tangent of x is going to be sine of x over cosine of x. Okay, and cosecant is the same as 1 over sine. Now, I went on and put these in because I know the video is going to be jumping as this goes along, because I don't want to waste y'all's time with seeing me type these all out. So it's going to jump around a little bit, as you already know. Now, when we multiply these here, well, hey, sine and sine will cancel out. And what that will leave us with is, pause, 1 over cosine of x. Now cosine of x, according to our reference sheet, our identities, is equal to secant of x. And that's it. So some of these here are easier than others in that we don't have to do as much. But that's it. That's all we have to do for this one here. Tangent of x plus cotangent of x is equal to secant of x times cosecant of x. Okay. So this one here, we need to convert tangent and cotangent into sine and cosine. I think it'd be easier to convert those into sine and cosine and then work from there. Now we could also have gone from this here, but I think this side here, tangent of x plus cotangent of x, is going to be easier to go that direction. Go from there to the other side. Okay, so if we convert it to sine and cosine, we get this here. Tangent sine. Okay. Okay. I noticed that I had squareds. They don't need to be squared. It just needs to be sine and cosine. So we have this here. So we have sine over cosine for tangent, and cotangent is cosine over sine. So we have these two here. Now, we want them, again, together, because if we notice the side that we're trying to get it to be the same as is secant times cosecant. So I need the denominators to be the same. So in order to get the denominators to be the same, I need to multiply both of these fractions by something. So for sine over cosine, well, I'm going to multiply the top and bottom by, not sine squared. Keep wanting to do sine squared. I'm going to multiply top and bottom by sine of x. So we're multiplying top and bottom by sine of x. Now for the other one, we're going to multiply top and bottom by cosine of x. Because when I multiply top and bottom by sine of x and cosine of x, we will get them to be the same, have the same denominator, so that I can add the numerators. And if I do this here, on top of this first one here, I'm going to get sine squared of x. On bottom, we'll have sine of x, cosine of x, plus. On top here, cosine of x times cosine of x would be cosine squared of x. And on bottom, we would have sine of x, cosine of x. And now that the denominators are the same, we can add them together. So on top of this fraction here, we'll have sine squared of x plus cosine squared of x. And on bottom, this is a little bit easier to just type, it would be sine of x times cosine of x. We have this here. Okay, so we're getting closer to what we need. Now, according to the Pythagorean identities, sine squared plus cosine squared is 1. So that means the entire numerator, the entire top part of this fraction, is just 1 because sine squared plus cosine squared is 1. And what that leaves us with is sine of x times cosine of x on bottom. Okay, now we're almost there. We're getting closer to secant and cosecant. Now, if I wanted to, really, we could break this up and say that we have two things multiplied together, because really this is the same as 1 over sine of x times 1 over cosine of x. Well, 1 over sine of x is cosecant of x, and 1 over cosine is secant of x. And isn't that what we wanted? Yep, secant of x times cosecant of x. Well, I have it flipped, but it's the same thing. And that's it. That's all we need to do on this here. So again, it's really just manipulating these equations to get exactly what I want to show is true. Okay, now we do have a lot more of these here because we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 left to do. So I will do more of these in class on... Actually, I'm going to just keep going through these here and doing these here. So if you're getting the hang of these, you can go on and skip to the homework assignments and give it a shot, give it a try. And if not, we can go over more of these together on Friday when I get back into the building. You know what? We'll do more of these on Friday, and I'm going to let you all try the assignment this here on page 361, problems 3 through 8, 10 through 24, even. Well, okay, I'm going to change this to, come on, 11 through 23 odd. So that way you can get, if you need some help, there are some in the back of the textbook to help you kind of get the answer. If you want to be able to, so I'm doing that so that you can be able to check your answer.